Good morning, everyone.
Good.
The portion of recursion and iteration. Now we will discuss the cases of recursion. Okay, so there are several cases which can be solvable by recursion. So we have already done with Fibonacci series, yes or no?
Yes, sir.
Okay, so
One or
let
two
us
examples.
let us now start with a simple case, and this is solvable by recursion. Okay. So in this particular case, what we need to print, we are going to print first 50 natural numbers using recursion. Okay. So this function, this is here when we will call this function, this is known as calling function. Okay. Whatever is called from main, this is known as calling function. And the function which reside inside the same function is known as recursive function. Recursive function. Okay, so here we want to print the first 50 number. Actually, this is not very good example of recursion, but still this is the example. Here we pass n as 1. We pass the value of n equals to 1. And now this function number print will start from 1. It will start calling. Okay. Give me 1 second. Okay, so this is the recursive function n plus 1. Now n numPrint function will call this function, and this will start printing. This will start 1. Okay, if n is not equals to or less than 50, then it will start printing. So it will first print 1. Okay, it will first print 1, and after that it will call the another function, and that is np1 plus 1. Now it will move here and start executing this function. Now this value is again less than or equals to 50. That's why it will print 2. Okay, you can see the output in right hand side. Now it will call np. What is the current value of n? Current value of n is 2. 2 plus 1. So it will print 3. And likewise, it will print 50. Okay, that is your np 49 plus 1. Now np 49 plus 1. So what will be printed? Actually, we need to deal with 48 plus 1 case first. So let us now deal with that case. Now our next call is np. Here I am writing np instead of numPrint. Okay, so now this is 48 plus 1. 48 plus 1 will print 50. Okay, will print 50. This number will be printed. Why this will be printed? Because no, this will print this will print 49, simple 49, not print 50. Now in the next case, 40 np 49 plus 1, it will start here, and because the number is less than or equals to 50, yes, number is less than or equals to 50 means number is equals to 50, it will again print the same thing. Means 50 will be printed. Now 50 will be printed, and after that 50 plus 1. Okay, np 50 plus 1. In this particular case, This will be 51. And now this condition is false. Base case reached base case. And now it will start uh, returning all these things. Actually, it will directly return to that function because not integer is written. Okay, each and every time this will return certain integer value, and finally this will halt the function. Okay, this is not very good example of recursion, but of course it is one example. So I think there is no doubt. If you have any doubt, you can ask. No doubt.
No, sir.
Now come to this example. This is very important example. Write a program in C to count the number of digits. Like suppose the program is suppose the number is 39261. How many number of digits are there? 5 digits.
5 digits.
Okay. So now how do we run this program? How do we create this program by recursion? So initially we start with this function. This is our main function. It is asking for the number, for the dedicated number. Then second is counter. Counter is a very important thing, and counter will count the number. Okay. So here static counter will be given because it will return the counter value. But why this counter is written? Okay, this is local counter, and this local counter will call the function. Okay, this local counter will call the recursive function. Okay, so this is our function. And here we input the number like 39261. Okay, now this is our main program. This is our main recursion program. So here we will start, and this particular function is what? Calling function. You must remember that which one is calling function and which one is recursive function. Now let me denote this function. Let me denote this function. ठीक है, ये मैंने फंक्शन को इस तरह से डिनोट कर दिया. नाउ व्हाट इज आवर स्टेप ऑफ इंडक्शन? So first thing is it will pass this number 39261. Now here I had used static integer value. Okay, static integer value will remain. If I am not writing 0 also, then also it will work. Okay, if I am not writing 0, because static and external keyword when we use, they automatically store this value as 0. Okay, initialize this value as 0. Now this function will be called. So here it is checking whether the function, whether the given number is equals to 0 or not. If it is not 0, then it will start, counter will be 1. Okay, now here in the first run, the value of counter is 1. Value of counter is 1. Now number of digit function will be called. Number of digit will be function for number of digits will be called, and I had denoted this function as f. Now what is the value? This divided by, so 39261 divided by 10. What it will return? It will return only 4 digits now. Okay, and this will be, the remainder will be discarded. Why? Because all the values are integer, nothing is float here. And now this function will be called. The first recursion call will be started calling. Now this function goes here again, and this function goes here, because still we are inside this loop. So this function will call this particular function. Okay, this function will call this function, and then new number is 3926. Okay, whether 3926 is equals to 0? No, it is not equals to 0. Then counter value for counter is 2. Here counter value is 1. Okay, let me erase this circle. Now again it will call the function because still this is not reached to 0. So let us call this function, and now new value is 392 3926 divided by 10. Okay, because already it is divided. Now again it will go here, and although counter is written 0, but it is static in nature. That's why the previous value will return. Now the value of counter is 3. Okay, and this function will call again function 392 divided by 10. So counter is 4. Now it will call again, and this is function 39 divided by 10. Now counter is 5, and then it will call function 3 divided by 10. Okay, so this 3 divided by 10 is nothing, but it is function of 0. Okay, so this is actually equals to function of 0. It is not approximately equals to function of 0. So this is function 0. And now you can see that when this is our base case, if function is there, then it will call function again and again. Now the value, if n is not equals to 0, then it will run. If it is 0, then it will return the counter. So what is the current value of counter? Here it is 5, and it is not move inside this. Why? Because this value is 0. So it will directly jump to this. Now this will return 5. Okay, this will return 5, and finally it will return 5. It will return 5 here also. It will return 5 here also. And finally the main function will return 5. Now let me show you the actual value. This is actually 392 392 3926. This is 392. This is 39. This is oh yes, this is 39. So that's why it is calling 39. And then this is 3. So finally this. So any doubt related with this program? Yes.
Sir, the function ending, sir, like it will count the whole thing throughout the recursion.
How it will end the function?
Yes, sir.
Yes or no? Okay. So here our function starts from here, no doubt. So let us run this function actually. 39261 is written. Now, what is the value of counter? Counter equals to 0. This condition is true or false? This condition is true. Now, what is the value of counter? Counter is 1. Now, what is the value of this function call? So I am still writing the function name. And what is the value of this? This value is 3926. Okay. Now this will call the function. Fine. We are not reached to return. We are not reaching to this return. Now it will again call the same function. Yes or no?
Yes, sir.
Now, what will happen here? This will be called as 3926. Now, what is the value of counter? It will be ignored. Why it will be ignored? Because, and it is not ignored actually, counter is now 1. Now, this condition is true and the value of counter is 2. So let me execute the same thing step by step. Here. Yes, this pen color is okay. So what are the functions? Function and counter equals to 0. I'm not writing here. If n is not equals to 0, then only what will perform counter plus plus, and then function will call as n divided by 10. Okay, and else, what else? It will return counter. Okay, so let us run the first call. First call is function of function of 39261. Okay, so this value, whether n is less than or equals to this is true, and the value of counter is 1. Okay, here I am writing counter equals to 0, and this 2 is static, so this is 0. Now in this particular step, function will call 3926. Okay, and after that automatically it will recursively call, and it will not reach to return. It will not reach to return. Now come to f of 392. Okay, so the counter is 1. The counter is 2 and 3926, actually 3926, and the counter is 1. This condition is true, counter is 2 now, and this function, this will call the function 392. Now it will return nothing because it is inside the loop. Now it will call function 392, and then the counter is 2. This is true. Counter is 3, and it will call function 39. Okay. Now function 39 will executed, and this is 3. This is true, and this is 4. And now it will call function 3. So again, function 3 will be called, and the value of counter is 4. This condition is true. That's why it is incremented to 5. And now function 0 will be called. And in case of function 0, this will not run. Okay, it will return counter. Okay, it will return counter. Counter to which function? This will return counter equals to 5 to this function. Which function? F3. Now F3 will return the counter to this function, and this will return to counter to this function and this function, and finally it will return the value as 5. Okay.
Yes, sir.
Because each time return statement is required, so this will return final counter, okay, all these values are returning the final counter. Okay, this is intermediate counter. So intermediate counter is 5 now. The static value of counter is 5 now, so it will automatically return 5. And finally this function will print 5. Got it?
Yes, sir.
Here also the same thing is explained. Okay, so 2 examples are now available, so you can see both the examples. Now come to next function, that is your, if you have any doubt you can ask.
Sir, understood. No doubt.
No doubt. Now come to this program. This is our program. Write a program in C to find sum of digits of a number using recursion. Okay, sum of digit. The same program 39261. of 5. Okay. What will be the output? So 3 plus 9, 12. 12 plus 2, 14. 14 plus 6, 20. 20 plus 5, 25. So answer must be 25. Okay. Got it?
Yes, sir.
Okay. Now, so what we need to do, we are simply inputting the number. Yes or no? We are taking the number. This number is 39265. 39265. Now we have used the calling function. Here calling function is used. We have used the calling function. So here calling function is used. This is our calling function. Now, so we will execute the function. I am denoting this function as function of n. Okay. So let us write the function of 39265. Now this function will check. This is our base case. Okay. And this is our next case. So what it will return? What this function will return? This function will return addition of two things. First thing is n. This is our n equals to. So what is the n? 39265 mod 10. So answer is how much? 5. Yes or no?
Yes, sir.
Second step is function of n1 divided by 10. So what is the answer now? 39265 divided by 10. Okay, now we don't have any answer for this particular step. We don't have any answer for this particular step. So let us solve this function. So this is our recursive call. Okay, this is our first recursive call and this is the value. Now we will call once again. So what is the current value of n? Current value of n is 39265 mod 10. This will produce you 6 and this will again call because it is not reached to this base case until this program will run until n1 equals to 0 will come. Okay, now so this is 3926 divided by 10. Again it will call, recursive call will be done here because of base case is not reached. So this is 392 mod 10 will give you 2. And here this is a function of 392 divided by 10. Again, we need to move ahead. So this is 39 mod 2 will give you 9 and 39, this will pass through 39 divided by 10. Now this is our 3 mod 2 will give you 3. This is not 2. Oh, how many times I had written 2? This is 10. This 2 was in mind due to our binary calculation. Okay. Now I am calling a function 3 divided by 10. Now it is reached to base case. Okay, this is equals to function of 0. So what is function of 0? If n equals to 0, then it will return 0. Okay,
0.
now reaching to we are reaching to this point. Now it will start returning something. Now, like in previous example we have seen na, so here return statement is given. So just try to focus on this return statement. Return statement says that whatever answer of current answer of function, it will added with this. Okay, so what it will return? 0 plus 3 will return 3. Yes or
3.
no?
Yes, sir.
Okay, 0 plus 3 is 3. I am writing boxed value for actual return value. Okay, so this 3 plus 9 will return
12.
12. This is actually function, value of function. Okay, this value of function. Now, what is the value of this function now? What value will be written here? So this is
14.
12 plus 2, 14. Now, this will return 14 plus 6, that is equals to 20. And now
20.
this will return value as 25. Okay, so this is addition of these two things. It is not tree, it is not decision. So now is it clear to you?
Yes, sir.
Everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, thank you. Now come to next. So just try to write down the step, then I will explain next. So I am giving you 5 minutes. Within 5 minutes, you need to write all these things. Okay. Done.
Yes, sir.
Okay. Now come to next problem. This problem is to find the greatest common divisor. Okay. So how do we find greatest common divisor? The fundamental is very simple, but let me show you by example. So this is our problem. And suppose the problem, if you want to find the greatest common divisor between two numbers, okay, I'm not using three numbers, I'm using only two numbers for two numbers. So suppose the number is given as 630 and 600. So what is the common divisor? So we can use the traditional method also. We write both the things simultaneously and we can start dividing. So if we start this number divisible by 2, okay, 2 3s are 6 and this will be the answer, then 300. Now we can see that this number is divisible by 5. So 5 6 are 30 and 5 3s are 15 and followed by 5 6 and this. Now again this number is divisible, yes or no? 3 ones are 3 twos are 6 and 3 ones are 3 and 3. Now it is not divisible, yes or no?
Yes, sir.
So now GCD will 2 into 5 into 3, that is your 30. Fine. Got it or not?
Yes,
Yes,
sir.
yes, sir.
Okay. So now this was actually, I don't know whether your school has taught like this or not, but my school in class fifth or third, fourth, fifth, this type of GCD we have calculated. Okay. So our focus is because number one and number two is input taken as input. Okay. And now we are going to find this function. And this is the calling function. So let us see how do this recursion will work. Okay, this recursion is very similar. If both the numbers are not equal, then it will jumble inside this loop. And if this is equal, then we will start, we will exit from the loop. Okay, so let us start with example of an denoted function a comma b. Now I am using this function as a comma b. So this is our function. And what is the value of a? A equals to 630 and b equals to 300. Okay. Now it will check whether a is greater than if a is not equals to b until this will run until a is not equals to b. Fine. So here we can see that a is not equals to b. That's why it will start running this program. And what it will return? It will return the function. It will return the function. What is the function? What is the function? A minus b. What is the value of a? 630 minus b. So this is 30 and b. B is 300.
300.
Okay. This example is very special kind of example because we are not using any multiplication symbol, but it will give you right answer. We will see it by 2. Now come to next iteration. Next iteration, and this case will stop when both are equal. Now, in the next case, we are here in else branch. So it will return function of 30 comma b minus a, 300 minus a. What is the value of 300 minus a?
270.
270. Now it will call function 30 comma 240. Yes or no?
40. Yes, sir.
Now it will call function of 30 comma
210.
210. Okay. Now this will call function of 30 comma 180.
180.
Okay. I'm moving from here to here because I'm not having sufficient space. So, or let us try when this will happen. We will, yes, key. Now, the next step is add 30 comma 150. Next step is add 30 comma how much? 120.
120.
F of 30 comma 90. F of 30 comma 60. And now f of 30 comma 30. Yes or no?
Yes, sir.
Now here you can see a equals to, all other cases are a is less than b. Here a is greater than b. Okay, a is less than b, 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 and a is less than b, and a is less than b. This is our stopping condition or base case. Okay. Now with this base case, what it will return? What value will be returned by this particular function? It will return a. What is the value of a? 30. So this will return 30. Okay. This will return 30. Ultimately, because the value of a is now 30, so a equals to 30 will be written. Similarly, 30 will be written by this function, 30 will be written by this function, 30 will be written by this function. और ये कब तक रिटर्न करेंगे? जब तक फाइनल रिटर्न ना हो जाए, है ना? This is the execution
Yes, sir.
sequence actually. I cannot write directly answer as 30. So these many steps we need to execute, and finally this will return 30 here. Okay, and this 30 will be printed here. This 30 will be written here and finally printed here. Any doubt? Now suppose if the greatest common divisor is not common, okay, for uncommon things like 3 and 22. This is our function. What will be the output? Whether it is working fine or it will give you incorrect answer. So let us see. A is less than B, clear cut case of A is less than B. So now what I can write here, 3 minus 22 minus 3 is 19. Yes or no?
Yes, sir.
So whenever you feel problem, just ask me, okay? All the cases are A is less than B, okay? But now A is greater than B is coming. So
Yes, sir.
this will be subtracted. So now this will become 2 comma 1, and again this will become 1 comma 1. Now A equals to B. This is our base case or stopping condition. Okay, now what value will be written? A. What is the value of A? Now it will return 1, then 1, then 1. Okay, so this is final. Clear? Any doubt?
No, sir.
So the same function, the same program is executed here also. So let me delete which example I need to delete. Both are kept here. Okay. If you are able to understand from here or here, both are the same example. Actually, I had not choose different example, but here two different examples are there. So you can see also. Now let us delete this slide. So may I explain this one, or tomorrow I need to explain? Because it is 12:08. If you have no class, then I can explain it here. Yes or no?
Yes, and next is break,
Yes,
sir.
sir.
Lunch break.
So whether you are having next class or just break?
Break.
Just
Break.
break, sir.
Okay, fine. So this is a program which converts binary to integer to binary. Okay, we are taking here binary number and it will return integer number. Sorry. Just opposite. We are taking here the decimal number and it will return binary number. Fine. Okay.
Yes, sir.
So initially we start with our simple example. We are checking here for, and I am denoting this function as function and number. Okay, any number. Fine. So let us start. Suppose this line will be executed. So input any decimal number. I am using 4. Okay, and expected output is 100. So the binary here 66 is given. I will explain in next slide. And the simple example I am going to explain here. So suppose function of 4 will be called here. Okay, just try to understand. Initially, the static value is given. Fine, static value. So whatever is not initialized, it is automatically 0. Because static and extern, both the classes by default initialize the value to 0. Yes or no?
Yes, sir.
See, our register and auto both stores garbage initialization. Okay, and other two classes, static and extern. Okay, initialize to 0. Fine. So this is our 0. Now let us start for F4, and it is much better to call this function here F4. What is the initial value? Initial value. Okay. This number, this condition is false. Yes or no? The decimal number is not equals to 0. It is true.
Yes, sir.
Now, what is the value of R? R will be decimal. What is the decimal? 4 mod
4.
2. It will produce 0. Then binary, I am writing simple B. Okay, mathematical steps I am writing. So B equals to B. What is the initial value of B? 0. Yes or no?
Yes, sir.
And all these are static. You must understand. Okay, this will change later on. So now B equals to 0 plus R. What is the value of R? 0 multiplied by factor. Factor is initialized to 1. So what it will return? 0. Now next one is factor. Factor equals to factor. What is the initial factor? 1. 1
1.
multiplied by 10. So now what it will return? 10. Okay. Now up to this step it is running fine, and it will call a recursion. Recursion of what? F of 4 divided by 2. Now what is the value? This is 2. So this is f of 2 will be called. And now let us do the associated calculation. So what is the first associated calculation? R. R is 2
R.
mod 2, that is 0. B equals to 0 plus 0 multiplied by current factor value is 10, that
10.
is equals to 0. And what is the value of factor? Factor is 10 multiplied by 10. Now it is 100. Yes or no?
Yes, sir.
Yes, sir.
Okay. Now come to next step. Next step is um, this will call function 2 divided by 2. So now this is f1. Okay. So with this f1, what it will do? R equals to 1 mod 2 equals to 1. B equals to 0. Initial B is 0. Yes. Plus, what is the value of R now? The value of R is 1 multiplied by
1.
100. 100. Factor. Current value of factor
Yes, sir.
is
Yes, sir.
100. Okay.
Factor is
So
100.
now it will return 100. And what is the value of factor? Factor is 100
100.
multiplied by 10, that is 1000. Okay. Now next call. Just check the next call. Okay. So whether the next call is this is function of 1 divided by 2. So that is equals to function of 0. Yes or no? right? It is integer, na? So integer is always in integer. You must remember in integer computation, 7 divided by 3 equals to 2 and 1 divided by 2 equals to 0. You must know. Okay. Now 0 is there. So this is our base case. What it will return now? It will return binary number,
Binary number.
and that is equals to 100. Yes or no?
Yes, sir.
Now this 100 will be, this 100 will be returned to this function. Sorry, wrong placement. So this 100, that is B is returned to here. Now this B is returned to here. This is your 100. And now this B will be written here. These all are mathematical notation. Okay. Actually, it is not mathematical notation. I had chosen all these equivalent. Okay. This function is chosen as f. This decimal number is chosen as n. And now binary number is chosen as b. So that's why this will be the answer. Any doubt related with this?
No, sir.
Now, uh, are you interested to solve one more example, or you will solve by your own?
Sir, you give the example, we'll try it out.
So 66 is the example.
Okay, sir.
Okay. So you need to start from very left corner, and I am showing this function only. Okay. Let me delete another line also. This line I am going to delete here. How much time you will take? 5 minutes is sufficient for you? So as 12:23, please show the answer. Okay. Try to show at least 1 or 2 iteration minimum.
Okay, sir.
Okay. So anyone has done something?
Yes.
Shahoj. So let me, you have laptop now?
Yes, sir.
Okay.
Sir,
So,
actually, I solved in my notebook.
oh, okay, okay. So fine. Just take the picture and post it.
Okay, sir.
Yes. Have you sent?
Sir, I'm sending in. I sent in WhatsApp group.
Okay, just WhatsApp group, C section.
Sir, I
Okay.
solved only 4 steps actually.
Okay. So see, Shahoj, actually you have solved right, but you need to solve in this way. The ladder case is very important. This
Okay, sir.
staircasing is very important in recursion. Okay. So don't solve because you saw that each and every problem, whatever problem I had shown you, every problem, okay, from beginning of your what natural number also, I had solved in the same way. So you need to solve in the same way, okay. So this will give you correct marks. I don't know whether this time a objective type question will be there or not, but this is the correct way to solve. Fine. So let us close this recording and
Yes, sir.
class also. Fine. So thank you very much. Have a nice day. Have a nice time. We will see you on next class.